In this problem, we have a 10 kilogram box that initially it's traveling to the right with a velocity of 6 meters per second. Then it is thrown to the cart that is initially at rest. And after the box lands on the cart, it continues to move to the right at a speed of 3 meters per second relative to the cart. And we need to determine the speed of the cart. We can neglect the friction between the cart and the ground. Therefore, we can treat the box and the cart as one system. And during this very short period of time when the box lands on the cart, there's no external forces significant enough to change the total momentum of this system. Therefore, the total linear momentum of the system is conserved. So we can write our conservation of momentum equation. We have at state 1 is right before the box lands on the cart. So the mass of the box times VB1, again, this is along the x direction. So that equals to, the mass is 10 kilogram, and then the speed of box initially it's 6, plus MC times VC1. But because initially the cart is at rest, therefore this entire term goes to 0. And because the total linear momentum along the x direction is conserved for the system, so this equals to the total linear momentum at state 2, which is right after the box lands on the cart. So that equals to MB times VB2 plus MC times VC2. So now from this equation we can write 10 times 6 on the left hand side equals to 10 times VB2 plus the mass of the cart is 30 times VC2. That's our conservation of linear momentum equation, but we have two unknowns, VB2 and VC2, so we cannot solve for both unknowns. However, we do have one additional condition. We know that the box at state 2 has a relative velocity of 3 meters per second with respect to the cart, which means that, again, if we choose right to be our positive direction, that VB2 equals to VC2 plus 3. In other words, it's actually the relative velocity VB relative to C2 equals to 3, but that equals to VB2 minus VC2. Either way, now we have two equations with two unknowns, so we can substitute this relation into the first equation. So we will have 10 times 6 equals to 10 times VC2 plus 3 plus 30 multiplied by VC2. So from this equation we can solve for VC2, which equals to 0.75 meter per second. And that's the answer to this problem, and we're not asked to do so, but if you want to, you can solve for VB2 as well, and that will simply be 3.75 meter per second. Both velocities are to the right.